Today we are walking through the paper titled Mathematical Methods in Human Thought in the Age of AI.
Give me the big picture first.
This paper is not introducing a new theory or more a new benchmark. It asks what AI is doing to human thought, especially in mathematics, and argues that the right goal is not full replacement, but human-centered use.
Why use mathematics as the test case?
Because mathematics gives unusually sharp feedback. Proofs can often be checked, mistakes can often be isolated, and that makes math a lower risk place to study what AI helps with and what it quietly damages before exporting those habits to the rest of scholarship.
So what is missing from older ways of thinking about automation?
The paper says earlier automation mostly changed communication, formatting, and computation around research. Modern AI pushes into idea production, explanation, and judgment, which means it now touches the philosophical core of a field rather than only its support tools.
What does that pressure look like inside mathematics?
Mathematics has an official ideal of rigorous proof. A proof is trusted not only because every line might be checkable, but because the argument shows strategy, insight, and a believable path from assumptions to conclusion.
What exactly is that smell test?
It is the experienced sense that a proof hangs together for the right reasons. A strong proof tells you where the heavy lifting happens, what is genuinely new, and why the method should generalize. A weak proof can look polished and still feel directionless or suspicious.
Then why not push all of the checking into software?
The paper is positive about formal proof assistance, especially because modern papers are long and human referees cannot line check everything. But formal verification only proves that a formal statement follows from formal rules. It does not guarantee that the formal statement matches the human intention.
Can you give me the concrete failure they worry about?
One example is simple but important. If an AI formalizes a famous claim with the wrong convention or the wrong translation from informal language into formal symbols, it can certify the wrong target. And even when the target is correct, a proof can be formally valid yet almost useless as explanation because it strips away the motivation and the narrative.
So the paper is not anti-AI.
Its short-term recommendation is a vanilla extract model. Small amounts can improve the dish, but making AI the main ingredient ruins it. In practice, that means using AI for limited assistance such as wording suggestions, organization, or checks, while keeping the human researcher in charge of the argument.
Where do they draw the line between safe help and risky substitution?
The paper proposes a red team role rather than a blue team role. AI is safer when it reviews, tests, or challenges human-made work. It is riskier when it becomes the primary generator of claims, structure, or conclusions that the human side cannot reliably verify.
Does the paper keep the discussion inside mathematics, or does it widen out?
It widens out a lot. The authors argue that AI deployment already has visible social costs. Skilled jobs disappear. Huge infrastructure spending concentrates power, and access splits between people with strong AI resources and people without them. So the governance question is not abstract. It is about who benefits, who pays.
Do they offer any constructive alternative to that concentration?
Yes, they point to smaller local models, proof assistance, and targeted community tools as healthier complements to giant frontier systems. The idea is not that small tools can replace every large model, but that more distributed and purpose-built tools can make useful AI access broader and less dependent on a few centralized actors.
What about credit and responsibility once AI is in the loop?
The paper treats that as a serious unresolved problem. If AI contributes to an argument or to the writing, who deserves credit, who owns the result, and who is accountable for mistakes? The authors also warn about citation loops, where AI-generated summaries become sources for later AI systems and gradually pollute the record they are supposed to describe.
Up to here, the message sounds mostly cautious. Is there a positive long-term vision?
There is. The paper ends by sketching a broader view in which human and artificial intelligence are not treated as identical, but also not forced into a simple hierarchy. Instead of asking which one deserves the center, it asks how different forms of intelligence can complement each other without erasing human values.
What keeps that from collapsing into simple replacement?
The paper's answer is that mathematics shows why replacement is the wrong goal. The field still needs explanation, judgment, motivation, and standards for what is worth sharing. Even perfect symbol manipulation would not settle those human questions. So capability alone is not the same as a good intellectual culture.
Then what is the main claim I should remember?
Treat mathematics as a controlled test tube for AI adoption. Use AI where it can be checked. Keep humans responsible for meaning and priorities. And evaluate every deployment by whether it expands human understanding on human welfare, rather than by raw capability alone.
And what limitation does the paper leave open?
It does not pretend to settle the philosophy of mind or produce a final policy blueprint. Its contribution is a framework for thinking, concrete risks, concrete use cases, and a human-centered standard for deciding when AI supports thought and when it starts hollowing it out.
So the safe reading is not ban AI or hand everything to AI, but verify, disclose, and keep the human purpose visible.
Exactly. The paper argues for careful integration, not surrender and not denial. Mathematics makes the trade-offs visible. And from that vantage point, the authors defend the human-centered path for using AI in research and beyond. That wraps up this paper walkthrough.